Okay, for the first part, for A, for example 6, they ask us, I'm going to write this down for you here. They say find the slope and they're going to call it M of the graph y is equal to the square root of x at x equals 4. So I'm going to run you through how to do this with both notations. Now, if you look back, if you go back a couple videos, you're going to see that there's one on example number 4. So example number 4 asks us to go ahead and find the derivative. So what they say is, okay, if f of x, which is our y, is equal to square root of x, then f prime of x is equal to 1 over 2 square roots of x. Another way of saying this is that if y is equal to square root of x, then dy dx is equal to d dx of square root of x. So what this says, this notation right here, is it says that we need to take the derivative the square root of x with respect to x, okay? Meaning that that's the variable we should see there. Now that's going to be important later when we do some implicit differentiation, but for right now, you don't have to be super concerned about that specifically. So this says, this says take the derivative of this. Well, we know what that is. That's equal to 1 over 2 square roots of x. Point being is that this right here is now a new way of looking at notation with the same answer. It still doesn't answer our question. What we want is, what is dy dx when x is equal to 4? Now this notation right here, sometimes they'll just write it as, instead of saying x equals down here at the bottom, they'll just put a number. And it's assumed that that's from this variable right here. Okay? So they want to know what is the derivative at this point. That is, this right here is the same as writing this. What is f prime at 4? They mean exactly the same thing. Well, we know that it's equal, dy dx at 4 is equal to f prime at 4, which is 1 over 2 times the square root of 4, which is 1 over 2 times 2, which is 1/4. So what is this? This is not the tangent line. This is the m value. This is the slope of the tangent line. Okay, that's what that is. Now for B, okay, so that's where we get the 1/4 from. Let me scroll here a little bit. For B, it asks us to find the velocity they're calling it v, so find the velocity v of a bus whose distance function given by f of t, distance is equal to t to the third. Okay, so then we go ahead and go through this. What we need to do, what we're looking for, is the velocity. The velocity is going to be a new function. So we've got a position function. This is really called a position function. Okay, and we need to find the velocity, and the velocity is going to be the derivative of the rate of change of position. So velocity is the rate of change of position, which is the derivative of the position function. So what we need to find is what is f prime of t, or what is dy dt if we said that y was equal to t to the third. Okay, so if we replace f of t with y, then f prime of t is the same as dy dt. Notice that the t's on here because this tells me what variable I should be seeing, what that I'm differentiating with respect to. Okay, so how do we find that? Well, again, dy dt, which is f prime of t, is equal to the limit as delta t goes to 0 of the following. It's going to be f at t plus delta t. Ugh, that's a t. It's not good. Minus f of t over delta t. If you want to replace these with x's, you can. You should just start to get used to writing with different variables. So our function is t to the third. So this is going to be the limit as delta t goes to 0 of t plus delta t to the third minus t to the third over delta t. Okay, and that is going to be equal to the limit as delta t goes to 0 of t to the third plus 3t delta t, 3t squared delta t, plus, let's see here, another 3t delta t squared plus delta t to the third minus t to the third. That's this guy right here. This is just this guy multiplied out over delta t. Now, if you can't get this, remember Pascal's triangle binomial theorem. So this now is the limit as delta t goes to 0. The t's to the third cancel out. Everything left should have a delta t in it, so I'm going to factor that out. So it's 3t squared plus 3t delta t plus delta t squared over delta t. So we're replacing. And that is the limit as delta t goes to 0 of 3t squared plus 3t times delta t plus delta t squared. And as I take the limit of that, these guys, this guy right here goes to 0, and this guy right here goes to 0, and so I'm left with just 3t squared. So f prime of t, which is dy dt, the rate of change with respect to t, that's equal to 3t squared.